Well, when you see these constellations of satellites, constellation being a group of satellites that perform a mission together, going up that are hundreds, thousands, tens of thousands of satellites, it really is just increasing the probability of a collision. And collision avoidance is where we can help.
Welcome to Tough Tech Today with Meyen and Miller. This is the premier show featuring trailblazers who are building technologies today to solve tomorrow's toughest challenges.
Today we have Louis Perna from Accion, and he's going to be telling us about his tough tech company where they're building Electrospray thrusters to revolutionize in-space propulsion. Louis is the co-founder and chief scientist of Accion. Welcome.
Thanks, Forrest. Really glad to be here. Nice to meet you, Jonathan. I'm very excited to be on Tough Tech today. It's a really cool concept for a podcast, and I always like talking about what we're working on at Accion.
I guess let's start out and just tell the viewers what exactly is an Electrospray thruster. We want to get people situated on this cool revolution.
What isn't an electrospray thruster, really? No. So electrospray is a physical phenomenon that occurs when you have a conductive liquid and you apply a high-strength electric field to its surface. And what happens is a breakdown of the surface tension and an emission of charged particles. Electrospray oftentimes refers more specifically in the propulsion world to the mode of this phenomenon where you get ions coming out, which are lighter weight than, for example, droplets. This can be used as a propulsion system because when you emit those charged particles in one direction, Newton says that you get a reaction force in the opposite direction. So just like any other rocket, mass being sent in one direction pushes you in the opposite direction, where you are an astronaut in space, you're a spacecraft of some kind. Generally, we work with satellites. The cool thing about electrospray is that there's a lot of cool things that differentiate them from other propulsion technologies, but it happens at a very small scale, so we can make extremely small propulsion systems. And the way that the ions are generated means that we actually run at very low power as well. So we've been working on this at Accion since 2015, full-time, and my co-founder Natalya and I were grad students at MIT, where we were first working on making this technology more suitable for longer-term missions and spaceflight. So
tell me about that experience in grad school. What was it like when you were sitting in lab and you were, thought about maybe turning what you're working on into a company?
Interesting. So the generation of the idea that this could really be a company came out of the fact that as we were working on the technology, the advancements that the Space Propulsion Lab under Professor Lozano at MIT was making, the commercial side of things and the government were coming to the lab and saying, this is a really compelling technology. The advantages that it promises for space operations are things that we want to start getting to customers, start getting to national defense. How can we get these thrusters onto our satellites? How can we buy them, really? And, MIT is a research university. It's not a for-profit business. So that demand couldn't really be met beyond perhaps a demonstration mission, science mission approach. So we said, hey, this is exactly what you're looking for when you're looking at a business and saying, is there a market for it, right? We have people literally knocking on our door asking to send this out into the field. So we created...
That's awesome.
Yeah, we created a company to start working with MIT to license the IP around the technology and start doing some business activities as far back, I think, as 2012. And over a few years, as we were still working, focusing primarily as students, the idea grew and the demand continued to grow, especially with the rapidly growing small satellite market. And we eventually got into MIT's Global Founders Accelerator.
Okay.
And spent a summer doing that, and that's where I really got my crash course in what it means to start operating as a business. And
Awesome.
that's
And interestingly, it's now called Delta V.
Yes, it is now called Delta V.
Were you the inspiration for that? They're like,
I like to
yeah,
think
we had
so,
these great
yeah.
rocket guys. Let's rename this in honor of them.
I was definitely, so when that transition was happening, my roommate at the time was an entrepreneur in residence at the Martin Trust Center at MIT, and he was consulting me on how exactly they should write the phrase Delta V, capitalization, symbol use,
oh, wow.
because I was his rocket scientist roommate.
We as a species have been sending stuff to space for over half a century. What was it that when you and Natalya were starting to put your heads together on this opportunity, was there an inflection point or something that changed in more recent times as you to become what would eventually evolve into Accion Systems?
I don't know that I can say the inflection point was really in our heads, but more in the collective zeitgeist of what's going on in the space industry. In that, all the way back as far as Sputnik and Apollo days, as a species, sending things into space was accomplished, but it was, we look back today and it looks very crude, and certainly looks very expensive to achieve some of those things. And by today's standards, also extremely risky for the humans involved. And as we have progressed as a world that goes into space, as a species that goes into space, things have gotten safer, more reliable, certainly much more high tech, and costs have come down, but really costs were still very high. With SpaceX starting in the mid 2000s with the goal of bringing launch costs down and seeing the industry really benefit from people going in that direction, and at the same time the incorporation of low-cost electronics into satellites, and the idea that not every satellite needs to be 5 nines reliability and super capable to do something meaningful in space, whether it's demonstrate an experiment or educate students.
So there was a shift from failure is not an option to, I guess it's an option.
Yeah, I think it was characterized during the shift as, a lot of people talking about disposability of satellites. Like, you build a satellite and a few years later, it doesn't matter that it burned up because it was cheap enough to replace. We've shifted back some from that, recognizing the value of an asset in orbit and in orbit for an extended period of time, and the return on investment that extending that time represents. But we were in undergrad and grad school, mainly, I would say grad school, when that shift was really starting to become a reality on the commercial side of things. And Planet, Spire, at a certain point, Skylabs, OneWeb, and then eventually Starlink and Kuiper all started emerging. A lot of those latter ones really once Accion was already formed, but the path was there. And seeing that, okay, the industry is shifting and the electronics part is solved. The camera is solved, except perhaps for figuring out how to get higher quality images from low-cost assets. But a couple big problems still remained, which was high bandwidth communication and propulsion. And propulsion is, out of those two, the one where probably by far fewer people are working on that challenge around the world, and fewer experts exist in that area around the world. Communications, there's always people working on that. So we saw Electrospray, this technology that is compact, efficient, lightweight, and the flavor of Electrospray that we were working on was mass manufacturable, so we could do it at scale for low cost, fit perfectly with this paradigm shift in the industry towards low cost assets in space, high number of assets in space. And really it just made complete sense to develop the technology to meet the needs of a changing business.
So how did you know it was mass manufacturable? Because, pretty much, before then just been a lab sort of experiment. Is it just inherent in the design?
It's inherent in the choice of manufacturing technologies.
Okay.
So we have within the thruster chip. So the devices we make in these little chips that are about the size of a penny, I would say is accurate. They're square shaped.
Wow.
And we can array them onto our product, which gets slotted into a satellite and then launched into space. So the part of the system that is the electronics and the propellant supply, that's all traditional manufacturing, and it's things that people have already solved the problem on how to scale up cost effectively.
Okay.
Within the thruster chip, which for us probably for other propulsion providers would best be parallelized to the thruster, what they would call a thruster head. The techniques that we're using in there are piggybacked off of the microelectronics industry, which produces billions, trillions of components every year. And so using the same tools, the same design techniques, and the ability to tap into that existing supply base and just, turn a knob that says instead of making 10, make 10,000, and watch the cost go down by a factor of 10,000 perhaps. We knew that we could produce at scale for much less. The thruster heads of other technologies, certain aspects of them can be scaled because they do use a lot of traditional machining processes, but some of those components have very delicate materials that you have to be very careful when you do produce them. And there are people trying to innovate around that, bringing in automated manufacturing and such, but really the cost is, I think, going to be very difficult to bring down on those technologies.
So how many have you made so far?
I wish I knew the answer to that.
Of those little penny-sized things.
It's definitely in the multiple hundreds, if not breaking 1,000 at this point.
Wow,
it's tough to say.
That's a ton for space.
Yeah, I started as a grad student working on manufacturing for this, so the quality and manufacturing records then are not the same as what we've set up eventually at Accion as a business. So I would have to go in and pull from databases to say, but we're currently working with outside suppliers to ramp up our production and start building them in the probably at the same or maybe slightly higher rate than we have been working on it more at the small scale, but the cost is going to go down dramatically.
I have a context question because of the ability to reduce costs, that this is playing into the emergence of like more and greater numbered constellations. So small sats, like for example, like OneWeb recently kind of going through bankruptcy proceedings, but that IP and other parts will probably live on in some other form, and SpaceX Starlink emerging more and more. What do you feel is Accion's sort of role and responsibility in terms of like the Kessler Syndrome, and perhaps explaining that for our audience?
Sure. So I'm not an expert on Kessler Syndrome, but I'll give it my best shot. And the idea is, so we have these things orbiting in space, and they're going thousands of miles per hour, and they're not all going in the same direction or along the same path. And so sometimes those paths cross and they can collide. We have to deal with space junk, space debris in general when, something fails initially or fails eventually and is going to take tens, hundreds, or thousands of years to come down and burn up in Earth's atmosphere. But when we have a collision in space, that generates many more pieces that are now flying around and spreading out. And when you have more pieces, you have a higher probability that another collision is going to happen. And Kessler Syndrome is essentially a situation where you have so many pieces that the rate at which collisions happen goes up, I want to say exponentially, until it's probably a logistic curve, but that's too many details. It goes up exponentially at a certain point, and you, in essence, ruin parts of the space environment for people to put new items or operate in general, because the chance of collision is just so high. And over time, these clouds of debris spread out, and so it only gets worse, and you get into a situation where if you don't have a way of cleaning it up, which is an extremely difficult problem, you have to wait tens of thousands of years for the situation to get better. And we want to avoid that at all costs.
It's a long wait.
It is a long wait.
And would that mean that getting through low Earth or orbit from Earth would be effectively impossible for a manned mission and perhaps even unmanned?
I don't know that I can say impossible because I haven't really looked into what it would take to go through a debris cloud. Certainly, something like the space shuttle, the space station, manned space vehicles in general are dealing with micro debris all the time. So really, it probably depends on the nature of that debris. Big chunks are going to be an issue. If we can track them on radar, then we can try to avoid them. But at a certain point, there's just too many to avoid. And so you have to have, I suppose, armored spacecraft. Maybe it does become impossible from a safety standpoint. But our responsibility as Accion, when you see these constellations of satellites, constellation being a group of satellites that perform a mission together, going up that are hundreds, thousands, tens of thousands of satellites, it really is just increasing the probability of a collision. And collision avoidance is where we can help. The international field of satellites has some agreements about what can be done in space. In the US, we have regulations around ensuring that when you launch a satellite, it's going to either be in a graveyard orbit or burn up in the Earth's atmosphere within, I want to say it's 25 years from when the mission of the satellite ends. And the FCC is currently considering additional regulations around maneuverability. Maneuverability is extremely important for collision avoidance. We can track these objects in space on radar, and predictively we can say, hey, these two objects are going to approach one another 5 days from now. 5 days, I think, is the standard for when we give people a heads up that their satellite is going to have a close approach with another object.
That's a stressful week.
Yeah. I've never been part of that, but I imagine so. Yeah. And so if you're talking about, a hundreds of millions of dollars or billions of dollars satellite in space that has propulsion on it, it has maneuverability. It can make some changes over the course of those 5 days to increase the separation at that conjunction event, I think that's what they're called, and reduce the probability that a collision will occur, because we don't know exactly how close they're going to get. They're going to get within some distance. The problem becomes when you have these lower cost satellites where they tend to be smaller. And one of the big problems for maneuverability is that propulsion technologies for small satellites are not well developed, and that's where we're trying to help fill the gap. So you may end up with a satellite that doesn't have propulsion, and so its maneuverability options are either none, or it can do something funky like rotate its angle of attack in the low drag environment to try and shift itself out of the way. And then there are, of course, non-propulsive maneuvering options. I think they really fit into a different category of propulsion still, but you wouldn't think of them as a rocket. Let's say they're not rockets. And those are, I would say, probably not the right solution. So we've worked on a product and have available a product that takes up half a U of a spacecraft, U being the 1 liter unit in Cubesats.
All right, can you explain that a little bit?
Cubesat is a standard that came out, I want to say in the late 90s, early 2000s, for the dimensions, size, interfaces of very small satellites, the smallest being a cube that's 1 liter, 10 centimeters on a side, and then some larger agglomerations of those cube units, each one of those being a unit. So a 1U or a 3U, which is about the size of a loaf of bread, a 6U, 12U, and it goes on until people start talking about numbers of U's that really are silly.
And for these U's, can you stack them in any direction, or do they just have to be like in a big long line?
Hey,
you can have a 12U snake satellite.
You can design whatever you want. You're going to limit yourself on who's going to launch it for you, depending on that shape. But most people go with standard shapes of just a cube, 3 cubes in a line, 2 lines of 3 cubes as a 6U, etc. And so with our half-U unit, you can take up a small portion of your vehicle and still meet a maneuverability capability. Not just one time, but multiple times. You can do, half a meter per second maneuver in space. Really much smaller than that, given our technology. But
so you're talking 10 centimeters by 10 centimeters by 5 centimeters, a little module, and then you can steer your satellite to safety when the time comes.
Yeah, and it doesn't take a lot to increase the distance between you and a satellite that you're going to collide with. It could take just a few hours of running the system, and you're going to add hundreds of meters of separation distance. And that's important for making sure that, let's say MIT puts up a very small satellite and it's going to collide with a very expensive asset or a set of very expensive assets owned by, let's say, SpaceX. They're not necessarily putting things in the same orbit, but maybe. Let's say it's a $250,000 MIT satellite is now threatening a $10 billion cost Starlink network with billions of dollars of future revenue allocated to it. You definitely, if you're SpaceX, you don't want that threat from a small university institution. So providing maneuverability to those smaller guys is I think critical for the future, and ensuring that those bigger players who have all that money and are putting up that expensive architecture are at the same time also providing maneuverability. I think they are much more incentivized to think about it because of the value behind their system. They want to make sure they're not ruining their own place to play, and that they're not ruining it for other people who have billions of dollars invested as well. So maneuverability, there's a lot of ways to do it. Propulsion is probably the most effective way, and it is, as we are proof, becoming affordable from a size, weight, power, and cost standpoint for anybody putting a satellite into space. And I think that our astronauts and cosmonauts on the International Space Station will be very thankful if you're able to move out of the way of them as your satellite drops through their orbit.
The size and the dimension of what Accion is building is small, like penny size. But the system complexity that it's sort of subsidized or feeding into is really great. As a company, and more specifically this is, at the end of the day, it's people that are working on this. What did you and Natalya think in terms of how we're going to decide to work together, and how do we figure out who we need to bring on board to help us? Because it's a big vision, very complicated systems that you're working on.
Sure. So Natalya and I are both technical co-founders, right? We both came out of the MIT Space Propulsion Lab just after she finished her PhD, and I left my work on my PhD to work full-time at the company. And building a team is probably the most important part of succeeding as a company. Your idea doesn't get done without good people, no matter how good of an idea it is. And so we have approached recruiting and finding the right people over the years in a few different ways. I think we've learned a lot, definitely, about managing of people once they're already on board. But finding the right people, my personal look at it is that I want to see someone who shows passion for the things that they're working on. So if I can see someone who, they're meeting a lot of the requirements around, skill set and knowledge, but even if they don't meet all of those, that they show that they're excited to work on what we're working on. They're excited about the long-term vision of the company. They're excited about the day-to-day work of the company. And they have demonstrated in either their schoolwork, their professional work, their personal life, that when they set their mind to something, they really achieve results. So looking at portfolios of hobbies or projects that they can share from prior work, class projects that they did as an undergraduate, their thesis work as a grad student. If I see that passion and that stick-to-itiveness, I know that they're going to be a huge asset for our team because they're going to bring that energy and passion to solving the problems that we have. Finding those people can be difficult. Relying on your personal network is always a good way to go because it helps with vetting people from the start. If you can associate yourself with hardworking, passionate, successful people, they probably know other people who are the same way. And we rely on, at the higher level, sort of the managerial company strategy level, on who our investors know, who our advisors know. And we rely a lot on our employee base to say like, hey, at my last job, I was working with this person and I think they would be perfect for this role that we've set up. And that makes it tough sometimes to not be too insular. If everyone's being hired out of the same network, you may end up with a lot of people who kind of think the same or act the same. So making sure that as you're doing this, you're being cognizant of trying not to slide down that slope of everyone's from the same background. And we're trying very hard to do that here at Accion. And I think opening multiple recruiting channels has helped with that.
So you've talked a lot about the, early on there was a lot of demand for a technology like this. You've talked about how, it's pretty simply scalable. You've talked a little bit about the tough challenges with, finding the right people. But we haven't really delved into like what is so tough, about your technology. Like you make it sound like it's just so easy. We make these thrusters and they're perfect and people want to buy them. Like what's the biggest challenge of getting these things to market?
And is this something I can do in my basement?
Insert rocket science joke here is the probably default answer. So what makes it tough? From a first order science level, I wouldn't say that the idea of a rocket and how to move things around in space is extremely difficult. What we deal with, the hard problems that we deal with, is more around manufacturing what we want to manufacture and knowing what the right thing to make is. Electrospray is a very under-researched propulsion technology. When you look at the whole picture of traditional propulsion, it's growing in popularity in the research community, but it means that we can't just say like, okay, here's the results we want and do some math. Here's the exact thing we should design and build. So there is a lot of questions that come up when we operate our devices around, okay, what exactly is happening at the fundamental level? How can we tweak that? How can we get more runtime out of the devices, more thrust out of the devices, more efficiency out of the devices? So we do a lot of work around using our engineering and science intuition and our fundamental principles understanding of what we believe is going on to guide our iterative development of the technology. And I think that has helped a lot in sort of operationally how we design things and coming up with ways to make leaps forward in performance. But I would say that at least historically, because that's, I think, something we're able to move into now that we have a bigger team more directly, historically, a lot of the challenges have been around manufacturing. And in fact, ion electrospray itself has been enabled by manufacturing and materials science approaches and innovations. So coming up with the right material for the thruster chips, the right material properties, and then ensuring that whether we're making those things in-house or getting them from out-of-house, that we have reliability and repeatability in that material and geometric result. It's a constant struggle, not only from assessing whether or not we have reliability and repeatability and figuring out how much does it matter? Where does it matter? Where should we focus those efforts? And then working with our suppliers, working with the tools that we have for manufacturing to try and improve those things. We spend a lot of time thinking about that and doing experiments to improve that. I think that our materials and manufacturing teams are working probably on the broadest projects and some of the most complicated and frustrating projects within Accion.
Sure. So lots of hardcore science and engineering mixed with just balancing everything else to make, the product marketable.
Yeah, I mean, I think
manufacturable.
Coming out of school, a lot of engineers and scientists will vastly underestimate how much effort has to go into supplier relations, defining specifications and requirements for suppliers, monitoring quality, solving quality problems when your supplier doesn't have the experience to solve them for you. And then sometimes you find amazing suppliers, and leveraging that relationship to be mutually beneficial and understand what it is they're providing you, whether it's a full assembly that you're buying or a raw material that you're buying or somewhere in between, how you can work together to grow the business and have a successful outcome. They don't teach you that in school, at least not the schools that I went to, because I didn't go to, not a manufacturing engineer or a business person by training. So that's stuff that a lot of people are learning on the job.
When you were becoming when you were an incoming grad student, did you have in your head somewhere like, I'd like to try to create a company around some sort of technology? Was that seed there, or was there some other story that helped it emerge?
For me, it was not there. I did not go into school at any point thinking like, oh, I want to start a company. I want to become an entrepreneur. I want to say that entrepreneurship in general has become, I want to say, a bigger, more noticeable part of the culture of the United States, at least. Starting since probably I was like a senior in high school, it's just been on the rise. But it wasn't something that was a career path that I even really thought was an option. And then in grad school, when the concept of starting a company came up, that's when I started getting introduced to that whole side of business and realizing, more so being exposed to options there. I think my co-founder, Natalya, was much more in tune with that. Coming from Duke, where she did her master's, she had started a company there. And so she had already gone through some of a founder's journey and had an interest in entrepreneurship, and led the charge, I would say, for our team in making Accion happen as a business, and fell very nicely into our CEO role, and has been doing a great job ever since working on the CEO role. And she's, I think, very interested in having more of the technology side in her role going forward. She is a technical co-founder, so having more of that in her daily life, I think, is something she looks forward to. And I can't wait to see the impacts that she's going to have on the technology side, because she's done such good work for us on the fundraising and hiring and building out an organization.
We'd love to have you back, have you both on the show, down the road. It'd be, and to understand that dynamics, because when creating a company on a project, no matter whether it's a tough technology or starting a hair salon, for example, when you have that partner, you must have experienced some of those like really difficult challenges that you were facing together, and that if you weren't both standing like shoulder to shoulder facing forward, that it could have fallen apart. Have there been some times over the past 5 or so years where it's like, this, like, people are telling us like this is too big of a project, like maybe I feel like quitting, but you didn't?
I wouldn't say that there's ever been, at least in my experience with Accion, pressure from the outside saying like, oh, it's not going to work out, give up. It's definitely, any company that you look at, that's, no matter how well it's doing, your perception of it from the outside is very different from the experience that the founding team or the employees are going through, it's definitely a roller coaster. So for me personally, there's plenty of times where it was very frustrating and demotivating. Things would happen, and it's just like, how much work is it going to take, to succeed and to keep going? Like, I'm tired. I just want to, retire to my farm and hang out there, with some cute sheep or something. But I think,
Jonathan's on a farm right now.
I should say, yep, did it.
Yeah. But those moments pass. And I think that the thing that gets me through those moments is thinking about the long-term vision of the company, really sitting back and reflecting on how cool it is that I get to work on what I'm working on, and be appreciative of that, regardless of how well things go or don't go. Stepping back, like, things are going to be okay. Nothing is ever really the end of the world. And the moments pass, and it's a really good moment to re-energize yourself around the mission of the company and the reason that you're there doing what you are doing. And on the side of, having a co-founder, I think Natalya and I work really well together in that, in a lot of ways, we're both very ineffable, and are able to let, scary things roll off our back in a lot of ways. And that we're always very honest with each other. And I don't think we have any big moments of having clashed heads and, really fought over anything. We always want to achieve the long-term mission of bringing advanced technologies to improve the space industry and give access to as many people as possible and make humanity a more space-present species. And the day-to-day decisions that have to be made, the day-to-day work that has to be done, it isn't always, let's say, obvious what the right decision is, but when you have the right motivation behind it, it's hard to get upset and disagree because you're facing the same direction.
Do you feel that space will remain the laboratory and domain of nation states, and that the sort of private or commercial sector influence is it's present, but still quite a ways off from what we may be hearing in the media?
I don't think that it will remain the domain of nation states. The timeline is, of course, I think the thing to really argue about, when is what going to happen and how quickly. We're already seeing commercial companies, I think SpaceX being the obvious, flagship company that anyone will go to, but plenty of others, showing that it is possible to get out there and achieve the same things that governments are achieving, cheaper and perhaps with different motivations. There's certainly way more resources outside of the Earth than there are on the Earth. Real estate, natural resources, etc., to be taken advantage of. Earth is, of course, our home and the only place that we were really evolved to naturally thrive in, and so it makes those other places less attractive. So bridging the gap between when we are poking our presence out into essentially low Earth orbit and really putting communities of people out into the solar system, or large sets of, for example, resource harvesting tools out into the solar system. Bridging that gap, I don't know what it's going to look like or how long it's going to take. A lot of the fundamental problems for people still exist around protecting them from radiation, living in space for a long time. But I think a lot of that will accelerate with the commercial involvement, and the focus, at least on the commercial side, the Earth focus on the commercial side, I think is the right way to go, because right now that's where all of the funding is. There's no customers on the moon, no customers on Mars yet. And so if you're going to have a space business right now, it needs to serve the Earth. And you can then, just like any other company in history, if you're serving the Earth and making a profit, you can invest that into the future of creating new marketplaces and new business ventures. A lot of people like to look at going out into space the same as the European continent going out into the oceans of the world and finding, quote unquote, discovering, quote unquote, new places. There's, of course, a lot of ugly history involved with that that I don't think we have to repeat going out into space. But a lot of the same sort of economic parallels exist around finding resources that are unclaimed and relying on the economy of where you came from to make those resources valuable until in the future a whole new economy emerges outside of that location and becomes self-sustaining.
Are there any components of your thrusters that can be created from resources from other places?
I've thought about that to some degree, and I wouldn't say that I've thought about it or analyzed it enough to talk with much certainty. The thruster chip itself is made up of mostly silicon and silicon oxide materials. So certainly there's a lot of that out in the world or out in space. And we can probably come up with ways to use other materials to do some of the same things. Setting up manufacturing in space might, be the real challenge. The rocks are there, but you need to do something with them.
What about your propellant?
Yeah, the propellant is probably the more interesting one in that it is a consumable. We have a organic and inorganic salt as our propellant. It's a molten salt. And I've looked at some prevalence graphs of different elements in the solar system, and a lot of the elements in our propellant are not too far down the list. So it is very feasible to me that they could be made from in situ resources. Again, setting up the manufacturing would be the challenge. One of the coolest things about the concept of doing that is these propellants don't evaporate in space. So, if you had a nice clean crater, you could pour the propellant into that as a pool and sort of, treat it like a lake of propellant that you could pump from. The idea of using, looking at our competitors' propellants, and how easy those are to come by. Noble gas propellants are going to be difficult just in a collection standpoint, but I think they exist to some degree. The higher mass ones are less common, is my basic understanding. And then people who claim to use water as a propellant, I think is a very compelling idea. Water is going to be one of the most valuable resources in space, so it's kind of like saying, we want to use our most valuable resource to just lose it for millions of years, probably. Okay. But it is somewhat abundant and interesting to use. If someone can come up with ways of using the more common elements, iron, nickel, silica, carbon, things like that, if I'm rattling those off at all correctly, they would have a lot of propellant out there, but those are some pretty difficult things to use as propellant.
How many satellites right now have your thrusters? Like, are they flying around up in space right now?
Fewer than I would like is the answer right now. We sent up a set of thrusters on a satellite. Now I want to say it was back in late 2018. Unfortunately, that satellite never communicated with the ground, so we never got to even try to turn them on. It was part of a SpaceX launch of a lot of Cubesats, and a very large fraction of them did not ever establish operations. So that was, I would chalk it up to bad luck. And we had a few launches scheduled in 2020 that have gotten some delays due to the pandemic, but we still expect a launch to go up in the September-October timeframe with operational deployment in December, and then another one is, I think, scheduled in January. So we've had a rocky history with reliability of launch dates and things, or things being canceled.
I'm still waiting for that Mars rover to launch.
Yeah.
Do we need more launch pads or what?
10 days.
But through MIT, the technology, when I worked on it as a grad student, we had a launch. And since then, there's been some more launches of the technology. I can't go into much of the details of how that went, but I would say that, Accion is still pursuing things. So the results are probably good in space. And so we look forward a lot to getting some flight data. Fingers crossed that the satellites are reliable and turn on and operate. And we can show some nice graphs of satellites rotating and changing altitude.
What's your opinion on very low Earth orbit and what the potential for sort of not quite, it's like higher than airplanes, lower than a typical satellite, maybe even air breathing propulsion systems? What kind of opportunities are there?
There's definitely a lot of people interested in very low Earth orbit. The main thing being better image resolution and lower latency on RF, or I don't think you have to worry too much about laser, but RF communications is the one where you get a lot of the benefits, I think. Propulsion is extremely important there just to counteract the drag of that environment. I suppose there are probably plenty of ideas where the satellites are being put there for temporary missions. I could imagine some temporary low-cost science missions that need to happen, disaster monitoring and relief. If you have a wildfire that you don't expect to last more than weeks or months that you want to be monitoring, you don't have to have a satellite that lasts 10 years. So those kinds of applications are compelling. Air-breathing propulsion is something that people have talked a lot about, and it's not something that I've personally worked on in any way, but it is definitely challenging to get the thrust levels that people want at that altitude. The trade-off between how much drag you're experiencing and how much you can really, how much momentum you can really impart from the ambient. I don't know that it looks amazing. So you really need to have, the thrust to power trade-off is not great, I guess, is a way of summarizing it. You're putting a lot of power into not getting a lot of thrust. But if you have the power, which, is becoming more and more available over time, then, and it's, free power, quote unquote, from the sun, or from microwave lasers on the ground or something, then why not do it? I just don't know that there's all that many fantastic engine designs that people really want to build into their satellites. But there's some cool ideas out there that don't take my word for how good or not good they are. I would say look into it.
Do you have advice for someone who's been, whether it's a technology or team who's coming from like a pristine lab, or the gentleman or gentlewoman who's in like an improvised workshop in their bedroom, who are building a cool technology and considering commercializing it? Do you have some advice to maybe the past you?
If you're coming out of a laboratory and trying to sort of stand up an operation yourself, it's way more work and way more expensive than you probably realize. The amount of resources that you're relying on in a laboratory environment is very high, and establishing the same ease of access and quality of things is a lot of work. At the same time, you have a lot of flexibility as to what you do and don't establish and when you choose to do so. So making sure you really think through a lot of that ahead of time and tap into resources that you have as far as people that you know on how to go about establishing those facilities and capabilities yourself the right way. because, I know much more now than I used to about setting up my own lab and manufacturing. But a lot of the lessons learned along the way were difficult and expensive. So making sure that you're tapping experts where you can to help you set up things the right way for the long term. And you can't always do things the right way because of resource constraints, but do the best you can. And also remember that not all advice is good advice. It's just advice. So making sure that you get second opinions and that you analyze things and don't be worried about like going against what someone said just because you're like, oh, well, they're going to see what I set up and they're going to see that I didn't do what they said. Don't worry about that. Do what's the right thing for you and your company. If you're coming out of a garage, you probably have a good idea of how hard that stuff is to do on your own. So that's not the advice you need. I think that coming out of both situations, it's important to realize that doing something in your garage and making it work and doing something in a lab and showing that it works once, or maybe you're showing that it works repeatably, is very different from setting up a business around it. Businesses have to have margin, and businesses have a commitment to customers around quality and reliability. Your customer wants a positive experience when they work with, I'm going to assume it's hardware, or really just call it your product, but they want a positive experience, and you want to make sure that you're providing a positive experience because they're where your money comes from in the long term. So making sure that you understand what it takes to scale up manufacturing, provide a good customer interface, talk to your customers and figure out like, hey, if I was going to deliver you this product, what would you expect from me? Create a list of documents that they want to see, pieces of information that they're going to need in order to make a decision to buy your product. Don't just assume that like, I know there's a market and I built this thing 5 times, and so people are going to buy it. Well, did you build it 5 times and they all came out exactly the same? Did you build it 5 times and they all turned on the first time you turned them on and you didn't have to tweak them at all? And you figured out how you're going to ship them and how you're going to have regulation, meet all the regulations you might not realize. There's a lot of stuff that businesses have to do that an experimentalist and a hobbyist, an inventor never thinks about. So talk to people who've done it before in adjacent, similar things. Hey, maybe even hire those people, and you'll start to do better.
Sage advice from someone who's done it before.
So we're coming up on the hour. Is there anything else you want to share with the audience?
Let's see. I mean, I think that people who are interested in some of the more detailed stuff around our technology should definitely look into it. You can find some resources online. You can go to our website and see some things. We're working on providing more info on our website. I didn't get too much into the actual fundamentals of electric propulsion and how Electrospray is different.
We'll save that for episode 2.
There. Yeah, exactly. And a lot of that stuff isn't too pertinent to the business. It's sort of the conclusions that come out of that drive the business forward. I would encourage people to check out who we're hiring for. If you're interested in tough tech and in working on our vision for going into space and making it more awesome, we've got careers posted on our website, so definitely go there. Check out our social media at Accion Systems. If you see me out and about when we're all allowed to leave our homes and shake hands again one day, feel free to chat with me.
Well, thank you very much for joining us today. We really appreciate your time.
It was great. Glad to be here. I always like talking about this stuff.
Thank you so much, Louis. In 2 weeks, we talk with Katie Person of the MIT Innovation Initiative, and we learn about the balancing act that tough tech entrepreneurs face when they work with the private sector and governments as clients. Please comment, subscribe, and share the show with a friend. Thank you so much.